Welcome back. So far, the problems we've worked on, you've gotten the total for the whole trip, the total distance and the total time. The average speed was given, and then you had to figure out the total distance and the total time. But usually in real life, things aren't work that way. Usually the trip is broken up into segments, and then in order to find the average speed, you have to add all the pieces of the trip. So these problems are a little bit more like real life. So that's what we're going to take a look at today. First thing we need to do is go ahead and fill out the STD triangle. Speed equals distance divided by time. Okay, and then you'll be given a problem with multiple times the distances. So the best thing to do is to make a chart like this that I have here. I need a table. You can just make a T-chart. For every time, there's an associated distance. For every distance, you can say there's an associated time. And we're going to add up all the times. We're going to add up the total distance. And then we're going to put those totals in the triangle to help us do the math. So here's an example. Michelle runs 15 kilometers in 10 minutes and stops to rest for 10 minutes. After the rest, she runs 25 kilometers in 20 minutes. What was her average speed? Well, we have all the pieces of the trip. We just don't have the total. So the first thing we need to do is ask ourselves, what is the question asking? Well, it's asking us to find the speed. It says, what is the average speed? So we're going to put a question mark where the S is in the triangle. The next thing then we need to do is fill in the other two boxes for distance and time. So we have to add up the total distances she moved and the total time for the trip. So her first distance was 15 kilometers in 10 minutes. So we're going to go ahead and put the distance in here, and we're going to put the time in. And the next part of the trip is she rested for 10 minutes. Well, while she was resting, she wasn't moving. So she would have a zero distance, but the rest is part of the trip. So we're going to include that 10 minutes. After the rest, she runs 25 more kilometers. So we're going to add in that distance in 20 minutes and add up the last time. Now we have all the information of the problem, so we can add up and get the total. The total for the trip is 15 plus 25. She went a total of 40 kilometers. And the total time she took was 10 plus 10 plus 20 is 40 minutes. Now we can go ahead and put our distance and our time in the triangle. So we're going to put the 40 kilometers where the D is and the 40 minutes where the time is, and we're going to solve. Okay. Numbers are up and down in the triangle, or top and bottom, so we know that we're going to divide. So we're going to take the 40 kilometers divided by the 40 minutes, because we have 40 kilometers over, that's what that bar in the triangle means, over 40 minutes. When we do that, we get our average speed was 1 kilometer per minute. Okay, our next section is acceleration. Okay, acceleration is a change in the rate of velocity. Okay, now it's important to remember that velocity is speed and direction. So when we accelerate, we can be changing speed. And this is what we usually think of when we say a race car accelerates. We think of it speeding up, or an airplane accelerates down the runway. It speeds up down the runway. But you need to be careful about this, because a lot of times kids don't think about the direction component. One of the kinds of questions that's commonly missed for kids on tests is it'll give you an example question, something like, a race car is going at a constant speed of 180 miles around the racetrack. Could it be accelerating? Well, yes, because it's turning. Even though it's going at a constant speed, it's changing directions. As they said, it was going around the racetrack. So because it's turning, it's accelerating. Another kind of common question that kids miss could be one like this. The moon travels around the earth at a constant speed. Well, you know the moon goes in a circle, so it's constantly turning. It's constantly changing direction. If it didn't change direction, it'd fly off and go in a straight direction, and we would never see our moon again. So because it's constantly changing direction, it's constantly accelerating, even though it's going at a constant speed. So anytime speed or direction changes, anytime you change speed or direction, you accelerate. So there's three ways. You could speed up, you could slow down, or, and I keep putting in all caps, you can change direction, because that's when kids usually forget about. When something speeds up, it's called positive acceleration. When something slows down, when I added in the notes, I just put in here a note to yourself. This is the one we usually think of when we think of acceleration. Okay, we think of, like I said, a race car accelerating around down the track, or we think of an airplane accelerating on the runway, or a car accelerating away from a stop sign or something. So we usually think of acceleration as speeding up. Negative acceleration is also called deceleration. Now, to calculate acceleration, we need to find the change in velocity. And we divide that by the time it takes. So to find the change in velocity, we take the ending velocity minus the beginning velocity, and this gives us the change in velocity. This is a general idea, and this is important because often in science on the SOL, or just in life, you're asked to find the change in anything. The change in anything, you always, to calculate the change in anything, you take the ending minus the beginning. So for example, think about it. This makes common sense. I ask you to say, what was the change in your height since birth? You take your ending height, which is what you are now, minus what you started off when you were a baby. So maybe you're 5.5 feet tall now. It's your ending height minus your beginning height. Maybe you were a foot long when you were born. So 5.5 feet minus 1 foot, your change in height would be 4.5 feet. If you do it backwards, you would have gotten a negative number, like you shrunk. So it's important to always remember you take the ending minus the beginning to find the change in anything. So the formula then for acceleration is the change in velocity, which is the ending velocity minus the beginning, divided by the time it takes. So the unit for acceleration is meters per second per second. Okay. Why are there 2 units of time? Okay. It's the change in speed and then how long it takes to change the speed. So let's say you're accelerating. I might go from 10 meters per second faster every second I'm accelerating. So for every second, let's say this is the car, and 10 meters per second. And I put my foot down on the gas. After 1 second, the car speeds up 10 more meters per second. And then after another second, it's going to speed up another 10. And after another second, it speeds up another 10. So for every second that I have my foot down on the accelerator, it speeds up 10 meters per second. So we would say it speeds up 10 meters per second, every second that we're doing the accelerating. Okay? So think about that because this is important with acceleration. There's 2 units at a time. So it doesn't mean something that you're more familiar with. If you think about miles per hour, when a car accelerates on a drag strip, we're going to say its acceleration is in miles per hour. The time it takes is going to be in seconds. So let's say it goes from 0 to 60 in 6 seconds. So that's about 10 miles per hour per second. So we would say the car accelerates 10 miles per hour per second. So after 6 seconds, it would be going 60 miles an hour because after the first second, it sped up 10 miles per hour. Then it keeps going for another second, and it speeds up another 10 miles per hour. That's why there's 2 units of time. When we calculate negative acceleration, the answer is going to be negative. So we would say it's slowing down. If the race car put the brakes on, we would say it slows down 10 miles per hour per second. Okay. This is also called deceleration, which is negative acceleration. Now, examples of acceleration are roller coasters. Okay. The reason why a roller coaster has so many twists and turns in it is because the people who designed the roller coaster know that you're going to feel acceleration when it speeds up, when it slows down, and when it changes direction. This is why roller coasters don't just go fast, but they go up and down and turn and twist and go upside down and around and around and around. And they're always turning because every time you turn, you feel a change in you feel acceleration. So by constantly having you change speed and direction, you feel like you're constantly accelerating.
Terms such as speed, velocity, acceleration, and deceleration are all associated with a description of motion. The rate at which an object is moving is called its speed. It is measured in units such as kilometers per hour, miles per hour, meters per second, or feet per second. Speed is calculated by dividing the distance traveled by the time it took. So if a car travels 80 kilometers in 2 hours, its speed is 40 kilometers per hour. Velocity is often thought to mean the same thing as speed, but there is a difference. Velocity is not only the speed of an object, but it is also the direction in which the object is traveling. So the proper way to refer to the velocity of an object is to include its direction, such as the car is traveling 40 kilometers per hour south.
So notice with velocity, they gave us speed and direction. So the definition of acceleration is a change in velocity. So if either of these change, either the speed or the direction that the car is traveling in, then we are accelerating.
Velocity changes if the speed or direction of the object changes.
Notice how when he says that, they're going to have the car go around turns. So you get the idea.
Someone racing around a track is concerned with his or her speed. However, an airplane pilot is interested in the velocity of the plane, meaning the speed and direction of flight. Velocity can be changed by changing the speed of an object, by changing the direction of an object, or by changing both the speed and direction at the same time. Acceleration is the rate of change in the velocity of an object. We usually think of acceleration as the speeding up of an object, but there is more to it than that. Acceleration is calculated using the following formula. Acceleration equals the final velocity minus the starting velocity divided by the time taken to change the velocity.
Notice the ending minus the beginning divided by the time it takes.
Suppose you are in a car traveling at 40 kilometers per hour, and the car accelerates to 45 kilometers per hour over the next second. The acceleration is 5 kilometers per hour per second. Notice that there are 2 units of time. Unit for the car and the second is rate. Acceleration can refer to decreases in velocity as well as increases. If the brakes of a car are applied, the vehicle's velocity decreases, and we say that the car decelerates or experiences negative acceleration.
Okay, so that was a good review of the ideas that we talked about on this page. We're going to stop here. You're going to answer these questions on your own, and then we're going to pick up here for next time, and you're going to solve some questions on your own.